Hello everyone. You might think this ordinary spoon is only good for stirring your coffee, but I'm about to show you how to give it a completely new purpose, capable of some truly amazing feats. I'm marking the center of the spoon with a marker. This spot will be where we make our initial modification. I'm securing the spoon firmly in my workbench vise. This is crucial for stability, as I'll be using a drill. I'm carefully drilling a pilot hole through the marked spot. A slow, steady hand is key here to avoid slipping and creating an uneven hole. I'm using a step drill bit to gradually enlarge the hole. This type of bit allows me to create a clean, precise hole of the desired size without tearing the metal, which is important for the components we'll be adding later. I'm placing the spoon handle into the vise, preparing to cut it. I will use an angle grinder to cut off a portion of the handle to secure the power cord. This modification is essential for the tool's compact design and functionality. With the handle cut, I'm now taking out the modified spoon. The precise cut ensures a clean edge for better integration with other parts. Here I have a terminal block and a spark plug. I'm going to carefully disassemble the terminal block by unscrewing these small screws. My goal is to extract the tiny brass connectors inside. These small, conductive pieces are vital for the electrical connections we'll be making. I'm taking this brass connector and carefully twisting them onto the tip of the spark plug. This creates a secure and conductive attachment point. It's important to ensure a snug fit for optimal electrical flow. Next, I'm preparing a red electrical wire. I'll strip a small section of the insulation from one end, exposing the copper wires. Then, I'm carefully wrapping this exposed wire around the top of the spark plug, right at the base of the brass connectors. This establishes our first electrical contact. A good connection is essential for the tool to function properly. Then, I'm attaching the other end of the red wire to the body of the spark plug, wrapping it securely to complete the electrical circuit around the plug. Now, I'm taking a different red wire. I'm carefully peeling back the outer insulation to expose the copper wires inside. Then I thread the copper wire through the cut-off spoon handle. I'm using pliers to really tighten down the wire around the spoon handle. This ensures a solid mechanical and electrical connection, which is vital for both safety and performance. Now, for an important safety step, I'm wrapping red electrical tape around the spoon handle where the wire is connected. This insulates the connection, preventing accidental shorts and protecting me from any electrical contact during use. I'm assembling the spark plug onto the spoon. I'm placing a washer over the spark plug, then inserting it to the hole in the spoon. On the other side, I add another washer and then a nut. I'm using pliers to tighten this nut securely. The washers help distribute the pressure evenly and create a stable connection for the spark plug. For the other end of the red wire, I stripped off the insulation. Then I threaded a washer onto the wire and twisted it tightly. This washer makes it easier to connect the soldering iron to the power source. For the core of our heating element, I'm reaching into my collection of batteries. I'm picking out a standard AA battery. The goal here is to extract the graphite rod from its center. This rod is key to creating a focus heat point. I'm carefully using a utility knife to cut around the battery casing and peel back the metal and plastic layers. You need to be very precise and cautious here, not to damage the inner components or yourself. After removing the outer layers, I gently pull out the black graphite rod from the center. This rod is a great conductor and will be our heating tip. I'm cleaning the graphite rod, and now I'm inserting it into my electric drill. With the graphite rod spinning in the drill, I'm carefully shaping its tip using sandpaper. I'm creating a fine pointed tip, which is essential for concentrating the electrical energy and heat for our future applications. The sharper the point, the more precise our work can be. Then, I'm carefully inserting the sharpened graphite rod into the top of our spark plug assembly on the spoon. I'll use a small screwdriver to tighten the connection, making sure the graphite rod is securely held in place and has excellent electrical contact. Now, let's prepare the secondary connection. I'm taking a white electrical wire and an alligator clip. I'm stripping the insulation from one end of the white wire and carefully twisting the exposed strands around the metal base of the alligator clip. A tight connection here ensures good conductivity for our power source. Then, I'm using pliers to crimp it down, securing it firmly. I'm taking a metal washer and threading the other end of the white wire through its center. Then, I twist the wire securely around the washer and crimp it with pliers. This washer will serve as a reliable contact point for our power source. For power, I'll be using this DeWalt drill battery. It provides a robust and consistent power supply, perfect for demonstrating the capabilities of our new tool. Now I'm connecting the white wire with the washer to the negative terminal and the red wire washer to the battery. This establishes a connection, preparing our circuit to operate. For our first test, I have a paper cutter blade and 2 nuts on a wooden block. I'll attach the alligator clip to the razor blade, completing one side of the circuit. I'm going to demonstrate how our spoon tool can be used for spot welding. See that? The focus heat from the graphite rod instantly heats the nuts, allowing them to fuse to the razor blade. This is essentially a miniature spot welder, created from everyday items. It's fantastic for small, precise metal joining tasks. It works incredibly well. Finally, let's test its ability to cut through metal. I have this small metal sieve. I'm going to apply the heated tip of our tool to the mesh. I have some soldering wire here. Watch me use the tip of the tool to touch the sieve, then insert the soldering wire. The concentrated heat will melt the soldering wire instantly, creating a strong solder joint. This homemade tool can be a lifesaver for quick repairs. The high temperature at the graphite tip makes it perfect for precise melting. Look at that, a clean cut, all thanks to our repurposed spoon. This incredible multifunctional tool, made from a simple spoon and some clever repurposing, truly showcases what you can achieve with a bit of creativity. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.